Hey everyone, welcome back to my YouTube channel. Thanks for joining me today on Workshop Quick Takes. Today we're going to be tackling the design and initial fabrication steps of a custom power and audio panel for the rear of a vehicle. Our subject vehicle today will be my 2000 Jeep Cherokee XJ, but you could apply this to almost any vehicle you want. The only thing you really need to be able to do is wire a heavy gauge conductor with a fused disconnect from your battery to wherever you want this to be. The hardware for wiring an audio amplifier works fine. If you haven't done that before, you might want to brush up. Today will be part one of two, and we're going to plan out the parts, some conventional, some unconventional, that you might not have thought of but work really well for this application. And then we're going to begin measuring and drilling everything to get it ready to go. Now, one interesting thing I've noticed is that whenever I tackle something automotive with an electrical component, the video seems to do better than some of my others. I gotta say, I have watched other channels where there are seasoned auto mechanics who can plastic gauge and then torque the caps on a big end bearing in their sleep, and yet mention something electrical, and there's kind of a bit of hesitation there, and perhaps with good reason. The three areas of your vehicle that can really burn it down if you do it wrong are electrical, exhaust, and fuel system, in not necessarily that order, but do it right, and there's really nothing to be afraid of with electrical. You too can do this. Just make sure you use the right tools, make a good compression connections when you need to, and don't pinch or bend wires around sharp objects where they might chafe through, and you'll be fine. Now you might also be wondering why I'm wearing my gloves. Am I already getting ready to go tackle this project? Yeah, that's the answer, and it has nothing to do with the fact that earlier I was being stupid with a hacksaw and knocked a big chunk of flesh off of my index finger here. Nothing like that at all. Best part, of course, I got like 5 pairs of these and wasn't wearing one of them. Would have prevented the problem. Your personal protective equipment is important. So, with that said, let's head over into the workshop and see what it takes to get this panel started. Alrighty, I want to create a panel that will provide multiple power sources in the back of my vehicle. Many modern vehicles, they'll have like a 12-volt port just pre-installed in the rear, and some more and more are starting to come with a 120-volt inverter also. I'm not planning to go quite that far, but what I do want is 12 volts, USB power, and some sort of hookup for my amplifier so that I can quick disconnect it. There's nothing wrong with quick disconnecting an amplifier, except for the fact that you're dealing with high current connections for the main power supply. And if you get careless with those and then reconnect it poorly, you might get a hot spot and then it melts the wire, causes issues. The vehicle I'm working on is a 2000 Jeep Cherokee XJ, but there's lots of vehicles, especially older vehicles, that don't come with the same convenience features that new ones have. So my first thought is, here is the right rear panel from inside this particular vehicle. I got to look at it and I was thinking, I could use this space to mount some auxiliary hardware, because the fact that this is recessed would kind of keep the plugs and connectors out of the way so they wouldn't get banged up by normal luggage moving in and out. However, this part right here goes far enough back into the fender that if I were to have a socket sticking out back here, I'm not sure if I'd trust it in terms of a clearance between the fender and the back connections on it. So then I got to thinking, well, I could actually make a panel that sort of goes in here but doesn't mount all the way down. How would I go about that? So I went digging through some of the bin of scrap aluminum, and lo and behold, I found a rectangular piece that was almost exactly the correct size. And what I did then was round a couple edges and then tweak this here so that it would fit in but not quite drop all the way down. So the fact that it does not drop all the way down in is because I'm thinking I maybe want to make a frame behind it that will offset it slightly. So let me just drop a couple of these pieces in here real quick and see what that might look like. Et voila. If I do have some sort of trim finishing piece around the edge here so that it just tucks in real nicely, I think that will sit at roughly the right height. And then whenever I mount onto it, I might have to make some hole cutouts behind here so that they penetrate through, but they won't go all the way back to the fender like what I was worried about the first time. So I think this here is a good starting point. Alright, next bit of goodness. What am I going to use for power connectors and such? Well, I went scrounging on eBay and I decided, first of all, let's see what's available for 12-volt power ports. And I found a couple configurations that I want to experiment with. I believe this one here is going to be the one I end up using on this panel. Something like that-ish maybe, I don't know. On the back side, it's actually 4 independent pieces. You have to wire them how you wish. This one here is a simple digital voltmeter. This one here is a power control switch and it's illuminated. This here is a 12-volt receptacle. And this is a power-only receptacle. It will take a device like that, but it will not take a lighter. It doesn't even, it doesn't snap in there or whatever, which is fine. And then this here is 2 USB ports at 2.1 amps each, I think. It won't do the 2.5 amp and higher quick charging, but that's good enough just to stop at one destination, run the GoPro for a while, move on. Then I can just plug it in and back and let it recharge and not have to worry about it. Another configuration of the same concept This one here is actually designed for a motorcycle or handlebar mount. So it has this little curved recess here, and then it comes with some brackets on the bottom. But again, same idea. There's a digital voltmeter, two USB power ports, 2.1 amps each, and then a 12 volt socket. And this one here, interestingly, is actually rated for a lighter. Notice how it has the ceramic base down in there to handle heat, and this actually came with it. So that one there. Let's just go ahead and plug one of these in. Well, plug these in one by one to a power source and see what they do. This here is a, well, it's a 13.8 nominal. It's not quite 13.8 volts. But let's go ahead and connect one of these to power just to see what it does. So I've got red and I got black. So DC positive, DC negative. Okay, so there it is sitting idle. That voltmeter boots for a second. Now it's saying about 13.5. Two USB ports, little blue lights, LED lights inside, because why not? Oh, look at that. It's actually cycling between incoming power and USB power, I think. So that's the gist of it. This one here I got to pay attention. Nothing's polarized, nothing's color coded, but I do have plus and minus. 13.6 volts. It wouldn't surprise me in the least to find that these both have the exact same chip in them. 13.7, yeah, so we're doing all right. Shut it off, watch it drop. Yep, there we go. So that one went all the way down to 4 volts before it died out. USB ports here, let's just take a quick look at those. Positive again. On that side now, negative there. A little blue back glow. And then finally, positive and negative again. Yes, blue lights in the bottom of the socket because why not? So the idea with this one here is nothing's pre-wired. You're supposed to connect it according to what you want, controlled by what. It's up to you, but since all of these are illuminated devices, I kind of strongly recommend switching all of them at once just to make sure you're not draining your battery. Alright, so there we go. That's a couple options available at about $15 each. For what I want to do here, obviously, I like the panel mount interface, which will probably be installed, I don't know, roughly the middle of the panel I think is a good spot for it. But then I have the question of how to get power from that much higher current feed, because that's going to provide power for the amplifier. But I was also thinking, hey, it'd be nice to hook that up in a way that I could also connect accessories, you know, like a medium-sized air compressor or whatever back there. So I got to thinking, what kind of connectors are out there that are commonly available and rated for that much current? And I started looking back on my audio experience. These are Neutrik Speak-On connectors, made in Liechtenstein. NL4MPR is the model number on this particular one. There's the Neutrik logo. What this is it's a 2, 4, or 8-pin connector, depending on how you get it configured, that's normally used for wiring up speakers in professional environments where you have a panel that your roadie sets up for you, and then you got to plug all your speakers into it. This here is popular because it's designed to be simple and yet rugged, and it needs to be able to handle decently high voltage, and it also needs to be able to handle current. As it turns out, each pin in here is rated 30 amps, and this particular one has 4 of them. And the way it does that is it's actually got 2 on opposite sides inside there, and the inner one, and then 2 on the outer one. It's a very well thought out design, and the other thing it is locking. Look at the parts and pieces real quick. Alright, so let's look at what the Neutrik connector has on this side. And you can also get inline versions of this, but in this case I am using a panel mount on this side, and then the cord coming out is going to have this. And this is NL4FC, female 4-pole original Neutrik product with hologram, not for use as a mains AC connector. We're going to try and use it for 12 volts at a maximum of 25 amps per pin. Okay, the connector, when you assemble it, it actually goes together like that. Well, first of all, you terminate your wires inside these very nice compression screw connectors. Get a closer look at it. Terminate your connections, and then that goes through there this way only. Next step is you have to pick the right size of compression ferrule here. This acts as also the strain relief. For this one, we're going to have a fairly decent bundle of cords, so I'll probably be using that one there. And then what happens is, for final assembly, you have this nice little grommet on the back side here. You can hear all that locking together really nicely. Once this is together, it's very rugged, it's not going to pop apart, and here's the neat trick about it. These pins themselves are not locking, so this connector here, looking at it, you can see that it has 2 on the inside pin and 2 on the outside sleeve. But what's going to happen is, when you go to plug it in, you'll notice it's actually offset from the thing here. Pull on this to put it in. You just push and turn, and just like that, it's locked. It's not going to pop out by accident, and it's not going to lose proper tension on those pins. Again, an extremely well thought out design, and not that expensive either. To release it, just pull that, and it's already ready to turn out, because the tension on the spring-loaded pins in there wants to push it back out. Just like that. What I'm thinking is, I'll go ahead and put these two on this metal panel somewhere. So we'll have this somewhere in the middle, roughly, and then maybe have these two down here. So in theory, I could use them both at the same time if I wanted to, and there's one master fuse back up at the battery, so you're never going to pull more than 50 amps from both connectors. But what I can do then is have two positive in parallel out of this and two negative in parallel, and the parallel current carrying capacity in theory would be close to 60 amps. One of these I'll wire up for the amplifier. If I need to pull it out of the vehicle, I'll just unplug this from here, along with the audio connectors. I'll be using two of those. And I think a little quick disconnect coming through a simple grommet will be fine for the remote turn on there. So that's kind of the gist of it, is to have maybe this up here and a couple of these. They'll need to be insulated because I don't want the grounds touching the plate, or I'll probably get a feedback loop, so I'll have to maybe put some nylon washers and some little insulation on there. We'll get to that in a bit. But in any case, that's my basic layout. I'm going to have to cut some holes for that. And then the other question is, what am I use for my cables on this? Here's where the world of RC is going to help me out a lot, because thanks to Radio Controlled Hobbies, it is very easy now to get silicone high strand count wire. This here, for example, 10 gauge wire. It actually looks thicker than 10 gauge because it has a lot of really fine strands packed in there, but it is 10 gauge wire. And it is supposed to be copper, although I'm hoping I'm not seeing copper coated aluminum there again. No, it looks like copper. In any case, this is 10 gauge wire, but it has 50 strands per side here, which makes it extremely flexible. And then it also has this really nice silicone insulation, which also helps with the flexibility. That means, you know, you can route it, bend it, whatever, and it's not just going to break off. Now, the reason that's important, here's a sample of 8 gauge wire, so slightly heavier even though it looks similar in diameter. Slightly heavier, but this is just for, you know, doing a battery cable modification. And it doesn't have to move around. You just form it in place once and you're done. And, you know, it's fairly flexible, but there's only, I'm not sure how many strands that is. Looks to be about 20 or so. So this here, yeah, it'll bend a few times, but after it's been, you know, moved around more than a few times, there's a real chance that some of those strands in there are going to start breaking inside, and then you get a resistive hotspot. But in any case, this is 2 5-foot strands, and this is 2 more 5-foot strands. So for my amplifier, 10 gauge will probably be plenty. I can take maybe only about 2.5 or 3 though, because the amplifier doesn't have far to go inside the back of the cabin there. Something like that. Maybe put a little bit of additional protection or string relief coming out of there, and then again over at the amplifier, and we're home free. For the other one, for the utility outlet though, what I'll have to do in order to ensure that I can get the extra current handling if I want it, is I'm going to look into trying wiring all 4 of these up into one connector, having 2 positives in parallel, 2 negatives in parallel, and away we go. So that part of the project is still in the future. For now, I want to focus on getting the panel fabricated. Okay, before we go to town putting holes in this plate, let's first make sure of where it is actually going to sit in here, and then work out our primary mounting holes. I'm thinking 4. I am planning to use a few pieces of this properly cut to act as underlying supports, and I'll either hide them out of the way or paint them or something. But first, I need to make sure that because this thing curves down and in, I want my mounting screws to actually hit a flat point and not part of the curved area. This one here is fine, that one there is fine, one more over here will be fine. 4th one over here, I'm probably going to have to inset it a bit to make sure it clears because of how this comes down and around, and that's fine, it won't be in the way of anything. So, let's just get a marker here, figure out about how far over I need to come. Probably, so I'm going to have a space there, one over here, 2, 3, 4. Go ahead and get those drilled, and then mark the spot where they hit down in this thing. Okay, there are my 4 primary mounting points. It might not hurt to actually do 6, but I'm not sure I need them. Instead, maybe I'll apply Gorilla Glue or something underneath onto the frame pieces and bond them down that way. An old and useful trick for making clean holes in thermoplastics is to heat a nail or other metal object until it is nearly glowing, and then make a quick, clean penetration of the working surface. Okay, so what I've now done with that neat little trick is I've punched through 4 precisely spaced little holes, exactly where I need them. And now I'm just widening it slightly with a drill bit here, keeping in mind though that this bit will bite into the insulation underneath. We'll flip that over and look in a second. Okay, so I see the burn mark right there, yes. Okay, 1 came through there, and 1 right there. At this point, I have only drilled out the pilot holes in the middle of the power panel positions where larger holes will be drilled later. Why? Well, because I want to also drill out those same holes in the plastic below. That way, when I drill out the plastic below, those holes will also be centered. Well, still got a little bit more drilling to do, but we're off to a good start because in spite of the odds against it, I got a nearly perfect alignment of the holes in the bottom sheet with the plastic top plate. So, as long as I drill these out neatly and if necessary over drill them slightly, then I'll have a perfect mount. And then these down here, I can't quite get them large enough. I need to get a stepper bit that is actually sharp, and then those will fit through. Okay, managed to get to the store, and it's a good thing tomorrow's a payday because these things are not cheap. At least not for the good ones. That's why I sometimes actually get and destroy the Harbor Freight ones, like these. They don't have any tolerable edge on them. They don't last long at all, but if you're just absolutely going to blast through one, you want to use one of those and not one of the nice ones like this. Now, granted, I got a pretty good long life out of this one, but let's see if we can look close. Not sure what it shows up on camera, but up here, especially from about here outward, can see all kinds of dings and damage in the edge there. It's kind of chewed in. Same thing on this, on the flute on this side too, which is actually damaged even worse. So this one originally had a carbide cutting tip on it, but it's junk now. I've completely trashed it. That's got a nice sharp edge on it. So let's see what kind of difference that makes. One thing I'm fairly confident of now that I was suspecting earlier is I don't think this is a piece of rolled sheet aluminum. Here's a piece of standard aluminum U-channel for reference, and I mean, this stuff is soft. I can blast through it with a drill, no problem. This here, just looking at the kind of curve it produces, it's not the usual long pieces that rolled sheet aluminum normally produces, but it's definitely not steel, so that's good. It's nice and stiff. It'll be perfect for my application, but man, it is a bear to machine. Alrighty, time passes, and here we are. So I don't have everything mounted up yet. I've still got to do a lot of cleaning and painting on this sheet, but that there is going to mount like that, and that results in isolation of the 2 jacks so I don't get any ground loops off the plate. The subwoofer connector is going to plug in on the back side of this, and I'll probably tape it just to make sure it stays secure, and then I'll have a second cord on the front side here. That way I've got a connection over to the subwoofer amp that, you know, if that cord gets damaged, not a problem. I can also plug and unplug it in order to remove the subwoofer from the vehicle when I'm traveling places with the family. So that's where that's going to go, but first I'm going to paint that black, going to paint this black, and then still have finished making the mounting frame that this is going to sit up on, as well as cut a few holes in the plastic bit. But we're getting a lot closer, and I think it's going to look pretty nice when it's done. Alright, earlier and off camera, I went ahead and got the old insulation off the back of this piece here, where I have to drill the holes through, because I'm going to need access for electrical connectors there, and I don't want to be surrounding them with this cellulose material. So just dropping that back down in there for a quick test fit. I can see that the holes I punched earlier with the hot nail are still in the right place. I'm going to flip this over and cut them from this side. These ones don't have to be precise because I just need access for the wiring, so in fact I want to over drill them. So I'm going to use, what is this size here? 1 3/8, which is larger than any of these 6, which are the 6 I have to drill out. I don't have to drill out behind here specifically. I can bring that wire in around one of the other ports. And then up here, I will need some sort of hole to bring through the audio jacks, but it doesn't have to be this big. I can make just one smaller hole back in there somewhere. Drop those back down again. I can see I've got nice clear access holes behind there. I'm going to need to make myself a small hole here to bring the audio jacks through, so... Actually, no. Those are going to stick out the back fairly far, so I do, in fact, need a matched set of holes back there. So I'm just going to roughly mark the centers of those. I think for these I'll just give myself a nice little pilot hole. And then go ahead and drill it from the back side like I did the others. Point of no return now. It definitely looks like Swiss cheese back here until I mount the plate in front. Little sidebar on this illuminated switch, just in case you're curious how these work. You'll notice it has 3 terminals there. Typically the idea is that one of the outer ones is power, the other outer ones goes to earth, and the center one is the switched power. And the switched power, when it receives power, then it also feeds an LED over to the earth pin. Just to give you an idea what that's like. I've got one here that I broke earlier, so I'm going to pop it open and just show you what's inside one of these. Physically it still seems to work, but the electrical connection is pretty well shot in there. So carefully removing this. Okay, here's the rocker switch. There's the LED, in this case tucked up in the switch. And here is a spring-loaded little kind of a metal button with some grease on it. Right here is a little flapper. And this little flapper, when it's down here, it touches nothing. But it's also rocking on this center pin. So the center pin is the power button, or is the power output actually. The power input is on this bottom one here. It then comes up, and when the switch is turned on, the little spring rocks forward and flips that paddle down so it's connected between the middle and the outside. The other thing you get from that is there is a little wire on here which is also connected to the middle button. So when you push it down, then there's power goes from that button through a little resistor and then through that LED, and the wire on that LED that you can kind of see there comes over and touches a metal tab right there. So you can imagine that little button right there pushing off, it's pushing it, keeping it away, keeping the button away from that bottom tab, and then when it comes this way, the spring-loaded button pushes this down, and power that is also going through the button, through the resistor and the LED, is also touching that tab there, and so that gives it its ground connection for the LED. Fairly simple device, and yet this one here I think was rated for 30 amps, so pretty stiff little guy.
Hey everyone, thanks for joining me today. Hopefully you enjoyed that part 1. Next time in part 2, we're going to get that panel painted. We're going to get a final assembly done, get the wiring done on the back side, and install that thing in the vehicle and see how it works. So, join me then.
Has anyone seen my phone?